Hi there, welcome. Today's episode is about HyperView and HyperView scripting, and I will base this on a example taken from the bridge builder. So it's not advancing the topic of the bridge builder today, but it is covering the HyperView scripting part, which I covered in the last, I think in the last video of the bridge builder, to a bit larger extent, because yeah, it's a topic where we could make a multi-part series. And partly because you requested it also to have a HyperView scripting tutorial, something like that, I think it's good to talk a little bit more about it on the workflow and how to get help and how to get also started with HyperView scripting, because it's not so easy as with HyperMesh. You don't have this easy command line TCL file where you can see what else, what your clicks are doing script-wise. But there's a help nowadays, and I don't mean the documentation, but I mean the actual scripting help. Let me show that in a bit. Alright, without further ado, let's jump into it. I think you all know HyperView. If you don't, check it out. It's a processor, and by the way, in this video I will be using HyperView in the old layout. You can, in the meantime, you can almost do every function also in a new layout. But because I'm more tend to use the old layout, or I know it just a little bit better, and I'm sure it works like I wanted to, I will use the layout in this. But the TCL commands should work either way, I think. Not 100% sure of that, but yeah, let's stay with it. So what I did here is opening a model. So I will just briefly talk about HyperView, how it's done, and I will mark set a skip mark for the scripting tutorial for all of those, for those of you who know HyperView very well. So basically, HyperView lets you examine your HyperMesh solved results. So you have pre-processing in a HyperMesh, for example, and then you solve it with OptiStruct, and now you want to look at the results. So what this is I think something from the bridge builder here. It's a model optimization _ des.h3d, right? And we have multiple options here, but I will just cover the most important ones. So I think the most important one is the contour plot, because this allows you to show a colored plot of various results. For example, here I have the element density available, and that's pretty much it. So I could select a component if I just want to have one component displayed, the stuff here in color. And I can choose averaging methods, filter, legends, whatever. But this does not show anything until you hit apply, right? So hitting apply will just show it to you here. And this is a bit specific about optimization and _des files, because here you always have to make sure you're on the right iteration, because this is the first iteration or the 0 iteration, and this will not have anything in the density because everything is just set to a standard value. Without this red line, this is because it was a non-design space entity, and so it has automatically the design value of 1. Changing here the iteration to, for example, 21, you can see that it changes the color now, and you can also quickly go through there and just see how each iteration looks. You can also do that with animation here. So by activating the play button here, you see that animation is running. And you can set the speed, but you don't see it doesn't change anything. That's because you have the wrong mode selected. So you're here in this linear animation mode, which is good for example, displacement contour results, where you're in the same iteration, but within different time steps, you could say. But changing that to the transient animation mode, you can see that the iteration will get iterated. See it also here. Alright, so this is it, contour value. The other thing is ISO value, which is also pretty important, especially for topology optimization results. there you can just display or not display any elements with a contour value of something above or below a threshold. So for example here, you see that I have contour plotted the element density. Let's say I want to have all the low density elements not displayed in here. So I just hit apply here. You can see by setting the threshold here, you can see that elements will get hidden. And this linear thing here is because of the averaging. Turning off the averaging method and hitting apply once more is it a more discrete thing here, right? So just on, off, nothing with average. All right, I think that's basically it for displaying something like that. You can measure, can deform. There's so much to do. Let's see. Let me make my mind up what to include here in this first tutorial. I think the most important things in HyperView to also show here, besides contour plotting, is how to actually show the deformation of a plot. So the real realistic manifestation of the value, like displacements, how to scale it, and how to measure or to output something like a value, for example. So in order to do this, I will need a second model, and this will allow me to show you also how to make comparisons and also setting multiple models in one HyperView session. So first thing is, this is a density file, and I would need a file which has actual displacement values in it. And for an optimization, this is outputted as _s and then the number of the load case, for example _s1.h3d, and I will show that to you. So first of all, let me change the layout here. I will choose a layout to have 2 windows here, or pages you could say, because windows, you have also additional windows here, which is a whole new window you could see, but it's also rather a tab than a window. But this will be added with a plus, so then you have 2 completely separated instances of windows and can switch between them. So I will call that pages. I think this is all the code page, yeah, page window layout, page window, both in here. So alright, so this is the pages, and you can see the separate layouts. And for each layout, you see this this light blue line here. This will indicate which is active. And you can also change, if you are in HyperWorks desktop, you can change the application which you are using here, simply by clicking here. You can, although you can just use one HyperMesh instance per session, but multiple HyperView instances. So just one page could be here, the HyperMesh instance, and all the others must be something different. Alright, so where were we? We were here. 2 pages. Second page, I want to load a model here, so open. And now I will choose another model. You cannot see it here. I'm sorry, this is just a window which is popping up. And here you can see I just have the _des h3d. Oh, that's not so good. But I think in the ctemp file I should have another. Well, it's just for demonstration purposes, but let me see. Des displacement. Should be something with, yeah, here it is. So _s1.h3d is the load case 1, corresponding to this displace, to this density file. So I open that, and you can see here that it's assigning this value, the string value of the path of that file, to load model and load results. Yeah, both. So you could, for example, make also that different. So choose another model file, but load different results, for example. Yeah, apply, hitting apply. Oh boy. So what happened here? You can see this is a deformed shape of of this S1 value, and this is terrible because yeah, the displacement is pretty high. So how to scale that down? You have this icon here, which will scale your deformed result, and here's the one, means this is real values. So in the length scale of this model, this deformation would occur. But you can see it's not realistic. But yeah, let's see how much it is. Just make a simple contour plot, and displacement is already set. And here you can see 30 millimeters is set here. And also you have a iteration, right? Iteration 0 will look like this, and iteration 18 will look like that. But for our demonstration, I think it's okay to use both ways. So this will look a little bit nicer, so I will choose that one. So iteration 0, you have this displacement, and let's see how you could exaggerate or make it less deformed. This is all done in the deformed section of the model. So clicking here once switches you here, and here you have the scaling factor, and you can also make the scaling factor not uniform but different in each direction. So for example, if you want to just exaggerate one particular component of the deformation, then you can do that as well. And scale factor, yeah, just this option. For displacement, I'm not aware if any other useful things work here, but yeah. So let's keep it with that. We have displacement here, and you also can do that in different systems, but the global system is fine here. So for example, if I put in here 10 and just hit apply, you can see it will, it will exaggerate the deformation here. So, and if you, for example, hit enter 0.1, then it will make it less. So now the deformed value is much more minor. Alright, so this is the one thing, and the last thing I want to show you in this very brief introduction here is how to output values. So for example, if I want to have the exact deformation of that node, there's multiple ways of doing that, but one is to measure it with the query panel. The query panel puts out information which is available, and we will be using that in the scripting pretty much as the standard way to go. And I think there is another one. Cannot find it here. Where is it? Here. Here's measures. So here you could also add a measure group, and query does the same thing in our regard. So let's start with query. If I click any node here, and you can see that I'm selecting nodes here, you could also change it to elements, for example. If I'm selecting a node here and I'm holding down my left mouse button, you can see the ID is lit up, and if I let go of the mouse button, this node will get entered here. And what you see here, standard-wise, is node coordinates and contour. And you can see that because those values are checked here. You could add multiple values here as well. For example, if you want a component ID as well, for the next thing here, you will see the component ID. Yeah. Alright, so this is it, and I think it's pretty straightforward. If you want to have this table then export it, you can do so. But just exporting that and save it as CSV document, for example. You can also clear it. So in measure, does the same thing, but here you have just one singular value which you want to measure. So for example, you can activate a dynamic min-max result, and then you can automatically see what the value is. And this measure group will change based on the result which is displayed here. So for example, if you change the iteration to 18, well, the nodes are maybe the same, but yeah, it would update. So 82 here and 81 here. So you see it's updating. But yeah, This is just one convenient way of having it always at the max, but you can add a user-defined measure group here, and you can, for example, distances is done here as well, but here you have the nodal contour if you're interested in having the values which are displayed here. So you just click here and you can see the values. And this is also good for post-processing, just marking your nodes where you want to have the results plotted here, and then make just a screenshot. Yeah, screenshot is pretty important as well, right, for post-processing. This is done here, and you can change if you want to save it to a file. This is this icon, and this icon is to save it to the clipboard. And this is just a switch. It will not do anything, but as soon as I hit here, it will capture the graphical area. You could also capture the panel area, but or I think manual dynamic rectangle. But the most used, at least by me, is the capture graphics area. And if I just hit that, I can now Control V into Word or something like that, and it will paste the image. Show that to you. Just opening Paint, Control V. This is, yeah, right. Why is it? Yeah, it's both. So you all just confused because I just saw the left one, but it is both. So you get your whole window, and also see that you have a white background here, not the blue background. So if you do a screenshot here, you can do that, but on paper you will waste a lot of cartridges. You don't want that. Make it the screenshot like that for your report. It's much better than that. We could go into automatic reporting also, but I'm there's so many things to explore. So, but let's stick to the topic. Today's video is about TCL scripting, and we will now jump right into it. So this was just a brief overview of HyperView, and now the TCL scripting. This is a script which was assembled during the bridge builder, and I want to use it as an example to just go line by line, and also to show you the help and show you how to actually get to such a script and what each line does. So it's a pretty basic introductory tutorial. It's not high sophisticated advanced TCL stuff here. It's pretty easy here, but nonetheless there's some lessons to be learned, and yeah, I think it's worth your time. So, you have HyperView here. I will just start a new model. And just make one page and start here, new model. The first thing which you will learn in HyperView scripting is that, well, you have your command TCL in HyperMesh, right? You don't have that here. Right now you just even don't have a TCL console, but you can display that via view and then TCL console right there. Click that and you have the TCL console here. And if you're entering something, you get auto completion here, which is useful and will help you a little bit because you may have to search for methods. And I do that pretty often, so this is a thing. But let's first go to the help document, because that's also very important as well, I think. So HyperView help, what I notice is that if you just press F1 here, you will get taken to a help document for sure, but it is not that precise. What I like to do is to go to the complete help of all components like that and enter my search keys here, because here I have experienced it that I find the values much quicker. Alright, and I want to start with here because there I can show you a little bit of something of the structure of HyperView, because it's object oriented and you have your classes which are depending on each other, and you have to move your way through there to get to the right class or instance to have your informations and also your methods available. because that is what's happening in the first part of the script pretty heavily. But first of all, let's look where we are. So you have HyperWorks help here, then you have the desktop reference guide, and then you have TCL TK commands, and then program with HyperWorks APIs for beginners. So here you can see for HyperView. So I'm just assuming I is for instance, but HyperWorks instance, and then session, then project, then page. So you see, the pages previously you have multiple of that, and you can have multiple projects for one session. And maybe multiple sessions per instance? Maybe. I'm not sure about that, but yeah. So you can navigate your way through here. And then you have windows, actually pages. No, I'm really confused. So let's get that straight. The ones here, those were windows. And I think this is then a page. I'm sorry, I will have to correct that. The pages are the different tabs, and the windows are the actual grid layouts for your models. Okay. Alright, help again. So if you want to have something like a session selection set, for example, you would have to move your way through here. And the best way is really to just Google for existing programs. You can also go into the script and model library and look for that. If you have access to the script exchange, that helps a lot to see what scripts are there. And also there are some examples here. So this is a place where I would start. So you can see here it's much more advanced than the things I'm showing here. But it's also a little bit more complicated. So you can put your commands in structured ways like a method. Yeah, you combine a certain activity you want to do maybe multiple times into a process here in TCL. And then you can call this plot combo processor multiple times. But I think for the beginner it's maybe a little bit overwhelming because all those columns and whatever. So this is just a way how to access variables in TCL. And this is just a norm, something users tend to follow. But for the beginning, I would say that's much more easy to start with something like that. And here you can see the basic structure, right? So you have HyperWorks instance get session handle ses. And this is a name, right? And this ses will get then used here. So you could make foobar here. It would work. And then you can assign, you can access the project handle from the session. Then you can get the page handle from the project. And here you have a first variable. And this is the active page, so the active page of the project. This page is then selected. And then you have the release handle, which, yeah, so it's a bit complicated, I think. But let's go to the script here shortly. So you see, the commands I just showed you in the example are pretty much the same like here. HVI get session handle session, session get project handle project, project get handle page 1, page get window handle window 1, whatever. You will set all those handles. And after you're done with a script, you should release the handle. And this is what it's taking into account here. There is a way to just automatically release all handles if you are done with a certain part of the script, which should be done by this HWI open stack and close stack. But in my experience, that didn't work at all. So if you had multiple ways of your scripts, multiple runs, and those commands are executed maybe twice, and you did not have a release handle, it will cause an error. We can look that up. All right, let's start with putting in the script one by one. And we have the script here, and I will just copy it over here and we do it one by one. So the first three values are just pretty simple. It changes the directory into some folder we want our output files to be stored at. And then it just sets two variables, and this is the import file path, which points to our _des h3d. And it will set our whatever. No, that's the second one. The first one was the out path. I think so. Here. Yeah, the commands are here. So change directory, this is the first one, out path, this is the second one, and import file path is the third one. So two variables and one change directory command. Now, the first thing we are achieving here is open stack. Stack open means that all the handles which are loaded in here get released automatically if you are closing the stack. But in my experience, that did not work all the time, so I'm releasing it manually as well. So what I'm doing here now is, and I used that command before. This is exactly what I was talking about. If you have used this command once before, you cannot execute it once more because the session object already exists. You could use another name. This would work, but let's see. If we close our stack here, and you see there how I get autocomplete proposals. So this is nice. Now, if I open the stack again, the command should be possible because the handles are released. And see, it did not work. Well, we don't care. So we have the session handle already. So I'm continuing importing the script. So now from the session, I get a project handle. And from the project, I will get a page handle. And just for simplicity here, it's hard-coded 1. But as you saw it here, you could also select the active page if it's something more interactive. Then maybe it's a better idea to select the active page. But for now, here this is fine. And now window, and window, that was the window layout here. So now window 1 is selected, and now we get the animation class. So win set the client type animation, win get client handle anim. So here I'm selecting a client type I want to have accessed. And here I'm accessing it. And now I have the animation class. And the animation class now allows you to have a add model. And this add model, so you can also look that up in the help. So here you have for all your TCL commands, HyperView. And this is pretty important. Why is it not here? It's not always there. Let's see, client. Sometimes, you have to navigate through there. It's not displayed here, but best thing is to just use the search. Add model should be available. Could be. Well, it's the correct code and it will allow you to see how it's executed, but it's not showing you the correct handle here. So better off maybe we have to get client handle. And here you should see your add model as well. So where are we? Here. Get client handle. But you see that really does not tell you anything. It's also in the wrong directory in the MotionView, which has the same commands, right? But it is not the one we are looking for. So this will maybe we just have switch that to that. I think that's the same, right? Yeah, it's also MotionView. here, HVI window. So here we are in the correct class, but you see there's not much in it. So you're better off using example files or navigating through all here. That's also possible, but it's not that bad for every method. Multiple methods are really good in the documentation here. Right, continuing here, we now have get client handle enum, and now we want to import the model, and we do that with the enum add model, now the file name, and we have the import file path, so we can use that. So we have a $sign for the variable import. There's no autocomplete for that, right? Unfortunately. Import underscore file underscore path. Typing skills. Alright, let's see. You saw that, so it was loading in the model and also the results. I think, no, not the results, just the model. And this was done automatically, but if you want to be sure that it's just animating this, showing this, is anim draw is just a, yeah, you can redisplay the things here, and anim clear is just also a command, which is just clearing your animation. I'm not sure why it is in there, but well, let's see. Maybe this part of the script was totally unnecessary, but yeah. Neither way, it's continuing with setting an ID to anim model import file path. I think this is because yeah, because I needed the ID. Maybe that's why I was clearing it once before, because otherwise I could not execute this code, I think. Yeah, but then, yeah. Maybe this anim add model command was unnecessary. Yeah, that could be. So set ID sets the variable ID to the value which is in the brackets, and in the brackets you have anim add model import file path, and you will use this ID in the next line of code, which is called anim get model handle my model and ID. So you have the model ID, and now you can set the results, which is the same file as the model as well. So my model set results and then the file path we used once before for the model. You could, for example, use different values here. And now again, just to be safe, but you see it's already there, anim draw. And then you can get your result handle. So from my model, get result control handle my result. And now you have that. And you can see here that you're in the iteration 0, but for this case, the purpose of the script is to export all the density values. So you want to change the iteration to the most current one. And the way you're doing that is by setting current to my result get current subcase. And this is the last iteration. Well, no, actually not. This is just, let me see. So in the next line of code, you have my result. This is the result control handle, and then you set your current simulation. This is set iteration 2, and then you have in the brackets an expression which calls my result, and then the get number of simulation of current -1. The -1 is there because I think it's because of an index. So you know that in an array, the first index is 0, and that's why you have the -1 in here. So this current gets you a subcase, which you're using here now for getting the number of results or number of iterations here, -1, and you're setting that with the set current simulation. So actually, this is a thing which I would want to see a little bit more in the documentation. So let's search for that quickly. If I'm searching for set current simulation, set to an integer greater than or equal to 0. But this will not tell you much. But then maybe the get number of simulations, how this is working. I think here you can see a little bit. This command returns the number of simulations available in this subcase. For linear superposition and envelope subcases, this command will return a value of 1. So you can also see a little example, and this is why it's important to have that. So get control handle. This was that, and then you have the result handle, get subcase handle 2. I think this is not done here. No. Let's see. That's more like it. So this is just sending it to a subcase ID. Okay, let's talk that through again. So from my model, you get a result handle. From the result handle, you get the current subcase. Let's see what this is. Get current subcase. I think this is maybe this. This command retrieves the current subcase ID. This is not iteration, no. This is not iteration, this is the subcase. And from the subcase ID, you go to the control handle, to my result control handle, and then get the number of simulations of the current subcase, subtracting 1 from it, and setting the current simulation in the result control handle with that. A little bit complicated, but what you're actually doing here is you're setting the iteration to the last iteration available in your current subcase, and that's what got me confused here, the subcases. But this is a necessary construct here, also if you just have one subcase. And that's why you can use the get current subcase, because you just have one, but if you would have multiple, then you could also change that, or maybe you saw that in the help with the envelope plot, that you could use that as well, right? Alright, let's not waste too much time here. So what this is doing is it's setting the iteration to 18, but it's not showing here, so I'm not sure why. But let's see if anim draw would change that. No, maybe it's just internally, but it has this in the result control handle, it is set. Okay, let's continue. Then you have data types, and this is a fun one. Data types is you get a data type list of the current subcase. And it's good that I looked that up. It's the current subcase. And the data types indicating what what values are available in this contour plot, for example. You see, it's the element densities, and this is also shown in the script here, element densities, right? So the element densities are available, and I will use this to set it as the contour handle, because that's the next thing. So set data types is set, right? And then we want to have the contour control handle, which is done by this command. And then we have the data types. So we set the data type, the thing we want to display in the contour, by a left index of the variable data types, which is this list. And we want a 0 index. So this is the first one. If you have a normal deformation model here, 0 would most certainly mean displacement. So, and 1 would mean stress. Alright. For certainly that's always possible to code that a little bit better, but I think it's okay. So now let's enable the contour, set enable state true. And now just for, see, animDraw actually displays now the contour value. I didn't click here apply, I swear. So this sets the contour value to true. And now you could actually use the query, because now the contour value is assigned. Because once more, the purpose of the script was to export a list of the densities. And now we have the contour plotted. Now we can access the contour value with the query control handle. And the query control handle we're getting with that command. So my model get query control handle my query. And then I have another variable set ID. So we want to have a selection set, because I want to have a threshold value, I think. But I'm not sure. Yeah. I would not need that anymore, really, but I have left it to be in here just to have it a little bit more general purpose. So to have a selection ID is good if you want to have certain elements assigned and others you don't want to have to assigned. So for example, if you want to output every contour value of every element here, but not elements with density lower than, for example, 0.1, then you could do so. But for here, it's you create a selection set here and set it to this ID, set ID. And now you have the my model, get selection set, lm set, and here the set ID. And here what you want to have in this lm set. Lm set add all. But you could also make something like, I think, contour. Let's try that if that's possible. Contour greater 0.1. Hopefully this worked. Otherwise we would get an empty list. But the default in the script here just has all. So it's elements add all. This is just what's happening here. But we now set something like this. Now, you have your query command handle, and you can now set the selection set to this query command handle with this command. And now this is a very important line. What you want to have. My query, set query, and then you have a string with values you want to be outputted, right? So you have element ID, contour value, element connectivity. This is the things you can assign here. There's a pretty good help document on that, which I will just quickly pull up here. I think we should be able to find it with set query. I will open both because I'm not sure which one is it. This is not it. Here, this one. This is perfect because not all values are available. So you can see what you have for node options, element options, part options, system options, and other result options. I know that I was missing really something important here, which was really a bummer. I'm not sure what it was actually. But yeah, this is a list. You can look that up. And now we have set that. Query is set. And now the out path. Haha. Maybe I should just quickly browse that directory and delete the file because I think it's there already. Let's see, the out path density file. So I just went into the directory where we are and just delete all the text files. Alright, so this is done. And now, because this line, which I will output here, will then write the query to the file. And now, see what magic happens. Oh no, is it the wrong model? 0, 3.9. Maybe refresh. Here it is, yeah. Thank God. But here you can see it did not work because our selection set is empty. So this is the thing which shows you that it's not working. Now let's see how we should do that. lmset add. I think I have to look that up. Let's just one more try. Git use contour.value creator 0.1. And now just write it once again. No, wasn't it? Sorry, I will look that up quickly and come back to you. Guys, spaces are important. So what I was missing was the space. So you see that we have put it something like here, like this in it. This did not work. With the spaces, it works. So don't forget your spaces here. So contour is greater than 0.1 will result in this file to be outputted, and you can see here now you have your ID, the density value, and your connectivity, which means the node IDs of each element, which is really, really helpful with the bridge builder. Alright, so after all this is done, nothing more than just resetting the session handles and closing the stack, just for the sake of completeness. And this is the basic script which is working here. So another quick tip: if you have the debugging mode here and you're trying out scripts and you copy pasting in all the time, if I just would copy paste that in here, it could work, but it could also crash the whole program. So you will in HyperView TCL scripting be hold to restart a lot more than in HyperMesh, because in HyperMesh you just say a new file, that's it. You can also do that with command file commands. So that's pretty, but in case of HyperView you would have to release all the handles, and if you're missing one, that's it. So you're screwed. So I'm trying that just for fun. Now this works, but let's see what happens if you have, for example, not releasing the handles, but solely depending on the closed stack parameter. Let's see. So first time it works, second time, oh, it works as well. Oh, good. I have this thing crashing on me multiple times, but it's good, it's working now. So make use of the open stack. It just costs you 2 lines of code, so this should not be a problem. And if you can get rid of the necessity to release every handle manually, and if you change something in the code, you have to change the release of the handles as well. So this closed stack concept is pretty good, yeah, so make use of it. Alright, I think this is enough for a first introduction into HyperView scripting, I think. What else we could do is, we have not touched anything with tensors, vectors, or maybe linear superposition of load cases and all those of advanced stuff. We could do that in the future, for sure, if you want. But for now, that's it for this video. Thank you very much for staying here with me that long, and I hope you enjoyed this tutorial and also maybe learned one thing or two. If you have any questions or comments, just let me know, and I'm happy to see you back in the next video. Take care.